So about me first, a couple of words. I actually started in this business when I say 30 years ago. It's not because I'm very old, it's because I started very young, and I started as host in radio station, doing some journalism work, etc. While I was doing journalism in television at the beginning, I was also editing my pieces. And then I basically fell into the technical domain because I found that journalism was kind of repetitive on a day-to-day basis. So I was more interested and focused on the technical aspect of it. But I still have a little bit of a creative side, so which makes me able to interface with creative people and to try to work out a solution that are friendly to what the creative wants to achieve, as well as have a very deep understanding of what the user are doing. I've done some editing, I've done camera work, so almost any job that you can think of in a TV station I've done. And then I built post-production houses in the 80s. I built a cable channel at Astral, which is the biggest cable operator in Canada. And then, frustrated by the poor quality of the tools that were available to us as user, I went on the manufacturer side. So I've done automation system. I've created iControl at Miranda, while I basically built the software division there as well as the software for the Kaleido. And then after that, I had the great opportunity with Current here to come back on the user side and to actually use some of the technology that I helped created to build this facility. So that was a great opportunity for me, and I'm very grateful for Current for giving me that possibility, not only here, but in building in the UK and Italy after that. So, and I came here originally for 6 weeks, and it's been a little bit over 230 weeks now. So I feel that mission is accomplished, and now I'm going back home and finishing my regular employment with Current next Monday. So that's enough about me. So here, the key, and I think, is it possible to just turn off a little bit the light on the front here so that we can see a little bit more? I'd like to keep it on the audience so that we can record it and to stream it online, but just to enable us to see a little bit better on this. That's better? Okay, so I'm not going to read all this, but one of the key requirements that we had to do, and it was sort of a little bit of soft requirement insofar as when I came here, there were 14 people here at Current. It was very, very early. And I think it was not clear exactly what we would end up doing there. Because when you're trying something new, something different, it's not hard requirement. But one thing that we knew was that we wanted to receive content from the viewers. That was one of the key thing there. And also, from the name Current, it needed to be very fast process to air. So we needed to find something which was lean and not expensive to build, enable a lot of volume to pass through without a lot of extra cost, model that is very distributed, and yet gives us possibility to bring that content from the viewer to air in a very short time and changing that at a moment's notice on air. So that was key requirement, and of course to very integrate and with the website, to have lots of dynamic text, and also to not look like anybody else. So in other terms, if a tool is used at Bloomberg and it has a certain look, then we don't want it. So basically, it raised up the challenge a little bit, because we basically most of the available tool was just the wrong decision because it would make us look like all the others would look. So if I just do a quick timeline of this project here, and I'm sure that some people will in this room will remember that. Takes a little bit of time. So basically, we don't see much of the text there. So basically, I came in December 2004 for the initial requirement. Then late January, the RFP was ready. We published it on January 24. Then on February 15, 2005, Ascent was selected as integrator. And we have Mark Sackett here. Raise your hand, Mark. Who was working at Ascent at the time and was the project manager of this project. So he can fill out some question on how it was hard to work with me during that time. And so we had equipment delivery basically from February to July. A lot of the equipment delivery takes a long time, and that's a factor when you have a short time frame to build something. When you choose the equipment, and here, since the requirement was kind of fuzzy, there's a lot of decision that we took during the build of the project with lots of change order and stuff like that. So the equipment delivery was a problem. We could not start construction before April 5th, and actually the construction of this space that you see around here was done until about mid-July. So we were installing equipment, Mark will remember that, while they were still building around us with the dust and all of this. We ordered the link with level 3 to LA in May. And then again, it's just at the end of July that we get the connection. And I will explain the role of that, because then during that short time frame, we actually added the full facility in LA that was not scheduled at the beginning. The LA studio was built from June 15 to July 15. We had the technical installation here. We started 24-hour full-time playing at Master Control on July 25th. Production here in San Francisco started in July 26th, and we were on air August 1st, 2005. That was a really, really short time frame for that. So that gives you a little bit of the timeline on how we did build this. So one of the key requirements of that was really the viewer contribution. A lot of the decision that we had to make on the technology and how we did assemble that was really linked to that. So what I've started to do when I came here is not come with baggage. I mean, I could have come here with knowing, okay, I know how to build a TV station. I did build a lot at the early 90s, and you put automation system, you put servers, you put different key component there, and this is how you do that. You have you have the tools, CG tool from Karen or from other manufacturer, etc. But I've tried to come here with an open mind and trying really to see what they wanted to achieve creatively and find a good solution for that. And one of the key things was the question of viewer contribution, because what it did give us is that we needed to easily and quickly be able to receive those contributions and being able to put it on air without having to transcode it and change a lot of that thing. Not only that, but we had before, because you want to have a certain level of quality on air, you want to work with these people from outside that are non-professional to try to raise their level of quality and their storytelling. So that means a lot of back and forth. So really, ideally, you want to work with the same tool that they do. So there's two-way interaction, and that also means that you cannot conceive your broadcast center as an island, meaning that you cannot say, okay, well, we have the broadcast is like a fortress, like most stations have, that it's not connected on the internet. So here, because we had to exchange a lot of data, not only with the user, but also externally receive files from everywhere that potentially can be contaminated with viruses and stuff like that, but also interact with our website, we could not build the broadcast chain master control as an island. So that was a key complication and a key requirement of what we had to do here. Whoops. Just a second, we'll bring you the microphone.
Okay.
Next time you can cut right through. So.
Yeah, I just wanted to just ask you to comment on how you were able to minimize the transcoding. It sounds like you would have to maximize transcoding. Are you talking about saying being flexible so that you would sort of elevate your capabilities over time? Or how did you achieve that?
Well,
very interesting to hear that.
In fact, what happened is that so that's basically this slide. So your question is perfectly in sync with this presentation. So you didn't stump me quite yet. So we did decide to use DV as the primary format. Why? Because the format that people had at home at the time, and it was early 2005, was really DV. So DV was becoming quite popular in the format that everybody had, so it made sense to use DV. And also, a lot of people were already using Final Cut, and especially since we're not looking for video of your cat, those kind of very low level, but we're looking at contribution that are a little bit higher in terms of storytelling. We thought at the time that a lot of those people would be using tools like Final Cut Pro. So it was a key decision that we would use Final Cut and DV that would match more closely with what they do use. And in fact, it did prove to be absolutely right, because more than 95%, and in fact almost everything that we end up airing on the channel was edited in Final Cut and shot in DV by viewers. So, so those assumptions that we did take at that point that we should be on Final Cut and on DV proved to be really the right decision, and we did save a lot of time by doing that, because then we just received the contribution either by uploading DV or by receiving a data DVD, like not an MPEG formatted DVD, but a data DVD with Final Cut Project on it, and just copying it on our central storage here and editing directly from that. So the back and forth with the viewer really become Final Cut projects, basically, with DV as the codec. So, and we use the same thing to put on our central storage as our central editing format, and as well as playing that directly from our central storage to air with Macintosh, with using Bug TV as the playout solution. So then, so it become really that we basically never transcode. So it's the same format from end to end, from the viewer contribution to air. And in fact, it turned out that the quality is impressively good, because a lot of loss of quality comes from changing codec and recoding the thing. And by keeping that way, and basically just coding in MPEG-2 when it's for the satellite distribution at the end, we achieve remarkable quality. If you look at current, compared to other digital channels, we look quite good actually. So, so that was another thing that we brought from that. So QuickTime DV 25 end-to-end, central storage for collaboration, and time to air. So the thing is that we have, at the beginning, we did put Xsan in place as central storage, which we replaced about a year after to Isilon. The Xsan is a SAN solution. The Isilon is a NAS, network attached storage solution, that did enable us to scale much more. Like at some point here, we had over 100 editing at the same time from the central storage. That the Xsan did not allow us to do that kind of scaling easily because of the structure of the tree network basically that you require to run an Xsan. But the Isilon did enable us to scale to that next level that we needed. But whether at the beginning with the Xsan or after with the Isilon, we did successfully play directly to air from that central storage. So we don't have to move any media to the desktop of an editor, and we don't have to move any media to a playout server to play it to air. It's directly from the central storage, which cuts the time. So as soon as something basically is recorded or is finished editing, we can basically put it to air. So that did fulfill that requirement of timely timely turnaround, as well as making sure that we don't have to transcode and lose time on transcoding at each of those steps. Also, another decision that we made early was no windows on the signal path. So I mentioned that since intrinsically we had to exchange data with the web to receive information from Google, to create on-the-fly graphics on the rising top search term, as well as exchanging files with user, the question of viruses and the protection of our broadcast chain was key, and Windows is particularly vulnerable to that. So we decided that anything on the signal chain will either be Macintosh or Linux or a version of Unix, but no window. And of course, that limits you on the choices of things that you can have in broadcast, because a lot of the tools are Windows-based. We have some Windows equipment. Here, for instance, the Mastec, which is our logger, is Windows-based, but that's a recording device, and it's not part of the key signal path that is used for.
I have a question about using Mac. Did you have any virus issues at all?
No, since the launch, we never had any virus issue. We had and I looked quite other stations that did with Windows. So it did prove like we've been on air now for over 4 years. That's yeah, correct, right? Over 4 years. I'm losing track of time at some point, and we never had any issue. So it proved to be a good decision.
So Stefan, that edict of no windows, did that then exclude potential current TV viewers from submitting things if they didn't have an Apple?
No, not at all, not at all. The thing is that what I'm saying is that we did not want any Windows machine in our signal chain. It doesn't mean that you don't use Windows to do creative work or any kind. It doesn't preclude you from using any tools to submit us content or interacting with us or anything like that. It's just that strictly on our key elements that are on the broadcast chain, that are the equipment that are our bread and butter and must ensure that we are on air 24/7 without losing a minute anywhere. that we don't want to have viruses and we don't want those machines to be brought down because we're basically much more open in our exchange with the internet. I mean, the internet is really integral to Current. So you cannot really say, we'll create an island where there'll be lots of check of file and stuff like that between the outside world and our master control. It really needed to be an integral part of our network here and of the internet. So this was a thing. But in no way does that preclude any interaction with the Windows world. And I'm not saying that in a way that is detrimental to Windows or to user of Windows or anything like that. I'm just saying that for the protection of our key element in our signal chain, we decided not to put Windows element there.
Stefan? Oh, go ahead.
That brings up another thing, because you now are mixing or potentially mixing files coming from a Windows environment and files from an Apple environment, and they're not necessarily compatible with each other. Did you have problems along that line, and how did you solve it?
Yeah, well, the thing is that, like I said, in practice, it proves that most content that we played that ended up on our broadcast network has been created with Final Cut. So in fact, the immense majority of contribution that we receive of the level of quality that we put on air has been done with Final Cut on Mac, so or with QuickTime, and so the rare occasion where it not has been the case, then you have in those exceptions, you have to then transcode to QuickTime or DV if it's been done with something else. But since it represents such a little percentage of the content that we did receive, it never proved to be a problem.
Stefan, talking about the original design of this facility and the ongoing maintenance, did you have to write a lot of custom code? I assume you did that in Linux, or did you do that in the Mac OS? And then do you have a lot of ongoing changes that you have to keep up with changing demands in terms of having to write new custom code? Is there a lot of custom code here, and does that continue?
Well, there is a different level. In terms of course, there is a lot of code written for our website, and for the tool that we want to increasingly integrate between Air and the website. So, for instance, the element that you saw in Joe's presentation about around the election, where a lot of those texts were done in Flash and integrated with the web. So those elements has been done in Flash, and the platform for playing them can be either Mac or Windows, and that is a little bit less problematic than the broadcast server itself, because if you have a layer of graphic like that and you lose that layer or something like that, you don't lose the core of your broadcast. So those elements have been done in Flash, and increasingly it's been done that way. We did write custom code on the Macintosh as well, integrating with the tools from Bug TV at the API level. And actually most of that code has been written by Yannick, who has disappeared. He was sitting right there. Oh, he's at the back. He's waving at the back. So Yannick is our Macintosh programmer that writes native code in Objective-C that integrate with the API from Bug. And this is how initially we did address specific graphic look, like the 4 bucks coming next, which is linked with our schedule, and have a specific logic that is custom. So Yannick, which is right here, has done most of that code.
So, in terms of the housekeeping type of control systems and so on, was that also some custom work of custom code on that? For
No, not in terms of
machine
housekeeping.
control.
Not in terms of housekeeping, because here we have lots of Miranda equipment, and the monitoring platform is iControl, and iControl does run on Linux. So the iControl server is done with Linux, and the code itself of iControl is in Java, so it can be run on the client side on Mac or Windows. That I know quite a bit because I designed it. So one other aspect that we did at Current is from the get-go, we had multiple sites. So at first it was mainly San Francisco here and Los Angeles, and then we added UK and Italy, and all those sites needed to be linked together. So that was something that was key, and not only for studio production, but for editing as well, viewing legal, because a lot of the creative and programming folks were in Los Angeles. A lot of the legal and editing were done here, and finishing, etc., was done here with Master Control in San Francisco.
With the viewer-created content, was there, who does the editorial on that? Is that all viewer editorial work on the viewer-created content? Do you?
It's a combination, and it did evolve as well, but there was a way on the website to vote on the content, and the best content will end up being chosen for air, but there's as well a team of people on the programming department here that were looking at those video and choosing video as well. So it's a combination of democracy, people voting for video, as well as creatively our programming team working with the community to select and choose which video would go to air.
There wasn't any interaction with the content originator?
Oh, yeah. There was, in the sense that once you select, once you say, okay, this video is interesting, now we're going to bring it to air. Well, at that point, the real work begins, really, because a lot of the people that create this video from their home at first, they're not necessarily aware that if there's music playing in the background, you need to have a license for that. If there's somebody in doing something significant in your shot, you need to have a signed release. So, there's tremendous legal aspect and a creative aspect as well to help their storytelling to be worked out. So we had a team that did specialize in working with them to help them through that process. But of course, once you do it once, then you're in a better position to do it again, etc. So that creates a community at some point that can create that.
You were going through your list of expansion: San Francisco, Los Angeles, England, and then you hit Italy. Up to Italy, we were all in English. What have you found in the language issues of adding another language to the system?
Well, it's an interesting question. It was not very hard to work with them because a lot of Italian speak English. A lot speak French also, which was easy for me. And but for sure, it creates additional cost in terms of you need to have some dubbing, you need to have some subtitling. But we were already doing some of it because the network from the beginning has been done as a very international feeling. I don't know if you ever sit down to watch Current, but there's lots of content that comes from abroad. And even on the channel here, we present things sometimes in Russian, And so you have things in different languages that are subtitled here. So we already did quite some work with international content in different language before. So it was not completely new. So I would say, aside from a cost issue and trying to find ways to be very effective in the way that we would handle those costs, it was not a big problem. There's always cultural issue and cultural shock when you're bringing people that have different background, different ways of doing television, etc., of course. And it was, there were some challenges, and it was a very interesting project indeed. Not to mention the regulation when you're installing stuff, the permits that you need, and all of this were all a significant challenge. And to do that in the time frame that we did was quite an achievement. Just to tell you, and I don't know if you saw that, but before we started the meeting, we were running a little slideshow of the build out in Italy. But from the time that we signed the lease for the studio, that was basically a car dealership with no studio facility, no nothing, to air, we had 5 weeks. So to demolish what was there, to put new ceiling, to build walls, to build studio, to install the equipment, to train people, and to be on air in 5 weeks is in Italy in a different language with other culture was quite a challenge.
Does your program material in Italy go out speaking Italian and subtitled as English, or does it go out? How do you handle which language you choose to put the audio in versus the subtitles in the native area that you're delivering the content to?
Okay, so first of all, I must say that all 3 channels are channel in their own rights. So either here, UK, or Italy, those are not translation from the other. Like each channel has their own host, their own set, their own studio. And so every time you see a presenter or a host of a show on air, it's native language from the country. So people in the UK are hosts that are at our London office and studios. People in Italy are from our Milan office and studios, etc.
Strange English language.
Sorry?
They're speaking that strange
in
British
UK,
British language, right?
Yeah. So, and the what we call pods are content. Well, it's wherever it comes from, basically. So, and in here, if it's done in, if somebody is speaking in Russian, you'll hear them in Russian and you see subtitle, and that's the same thing in the UK. In Italy, however, because of some cultural issue with the fact that people don't like to read subtitle, we dub a lot of the foreign content is dubbed. So you will hear a little bit of the person speaking in their language, but you will hear a voiceover. However, in Italy, we have 4-channel audio that are selectable by the user on the Sky Italia platform. And so if they switch to the first pair of audio, they will hear all the Italian language all the time. If they switch to the second pair, they will have natural language. So say that I don't want to hear that voiceover, I go on natural language and I can hear them. If it's in English, I will hear it in English, if I understand English. If it's in Russian, I can hear it in Russian if I understand Russian.
We were talking before with Joe about video over IP and the future of that, since this operation really has 2 sides. You do have a video over IP operation that allows your viewers to vote on what goes up on the cable systems, right? Then, of course, you have your cable feeds. Talking about that video over IP side, number one, what are the challenges that you've experienced, encountered with keeping keeping that video over IP flowing and with glitch free, and what do you think is the future of that. Some people say that because video over IP is still point to point, that the whole thing's going to collapse someday as more and more people, as I have, I now watch all my TV over my PC, my Mac. So where does what are the possibilities and what are the dangers of video over IP, and how does that apply to current in the next 10 years?
Yeah. So, I'm not a business person, so I will not address a question that is more business in the sense that I think the question is not so much technical than it is how do you pay for it. Because what I mean by that is that there are multiple ways to deliver content through a company like Akamai and Limelight, etc., that do specialize in caching some content and delivering it to multiple locations. So technically, it's not really a problem to scale it and to stream. It's expensive, though. So the question is that with more people consuming that content online, is there a viable economic model for doing so? But technically, it's possible. I don't think that we're running out of bandwidth. I think that there's more and more bandwidth installed, et cetera.
That's really my question: is where do are we going to run into a brick wall or a ceiling in terms of the ability of so-called Internet 1 before we get Internet 2 of gigabit capacity? With our current internet and what we're looking at over the next, say, 5 years, might there not be a limit where this thing will crash into a brick wall because there are just so many people demanding so much content, so many bits?
Yeah, the way the internet is structured, I don't think so, because it's really, internet is by nature, it's not one thing. It's a lot of network interconnected together. So whenever you see that you don't have the bandwidth that you need, you will actually pay a little bit more to have a better level of connection for your service, and in turn, that service pay a little bit more for its for getting a better access to the core of the internet, basically. So, I don't see that collapsing all of a sudden. I don't see that as possible. But I'm a television expert. I'm not an internet expert. So what do I know? So you kind of stumped me a little bit there. So yeah, I was speaking of multiple site remote production. So. And the first thing that we did initially, because the time frame that we did build LA was very, very short, and we had built here already the control room that you see in the back there. We didn't have time to build a fully installed control room with lots of capabilities, etc. So we said, okay, let's minimize the cost up front in LA. Let's build an infrastructure that enables us basic functionalities, but also enables us to send 3 video signal and 16 audio channel to San Francisco here, so that we can basically, with the video control room and the audio control room that we have here, take full control of that stage in LA and use it as if it was just next door. So, and it was actually a challenge. We needed to have those signals coming in, the return, and full intercom integration as well. So, sorry, question?
Yeah, I have a couple questions. One of them relates to this, probably where you're going, but did you ever have a point where you had a bottleneck on your network because you're obviously using some sort of fiber OC something to go from here to the outside world to where your satellite uplink was? And for instance, during the election time, if you ever had so much traffic, network traffic, and traffic going back and forth between the 3 facilities where it just,
things came to a a grinding or slow halt for your network traffic?
No. There are congestion time. I mean, there's always, at peak time, you always want more bandwidth. You always want more. But I cannot say that we had a situation where we could not operate because there was not enough bandwidth. So.
My next question is a workflow question on, I'm curious as to how long it takes from a piece that is downloaded and received here to when it gets to air, and how many steps that it goes through and how many people's hands it goes through before it goes back out to air.
Well, that varies greatly from country to country, basically, because it's the question of how many steps of approval creatively or legally that you go through. But it can be something that goes very, very quickly, like sometimes when, like in the time of Katrina, when we receive video from people that send us footage there, it can be anything from a few hours to weeks, because if somebody sends us stuff that we're not happy with the document that they're giving us for the clearance, or you hear music that they're not cleared, etc., it can be quite a hard process to go through. But I would say this vary from a few hours to weeks, days. So what I wanted to share, and it's actually very linked to your question, is how we did build our network. And originally in 2005, what we did build was the following structure. Here in San Francisco, we have a colo site that is about 2 blocks from here. And from that colo site to our production center, which is here, at the time we had an OC3, which an OC3 is a link at 155 megabits. And we operate it as an IP link, basically. OC3 is a SONET infrastructure, and you can operate it on ATM, but since we had point-to-point links, there was no point in doing that, so we operate it as what they call packet over SONET, so directly using IP over the SONET infrastructure. So OC3 to the colo site, and from the colo site to our LA studio, an OC3 as well, so same speed. And an IP port, which at the time was about 100 megabits per second, that connects us from the internet for the need of our website and browsing, receiving content, etc. The reason that we did decide to put a colo facility here is basically that this link here, which is a long distance link, is not very expensive, but this link here, which is 2 blocks, is. So local loops in telco terms tend to be very expensive. So instead of having one internet IP port plus a local loop for the internet and one OC3 local loop for the one to LA, we decided to put a colo in the middle to basically aggregate outside link and to have a single link coming in this facility. And that design after that did prove to be very economical to when we grew for more link, which I'm going to show after. But first, I want to mention that when we did that, with that OC3 link, we didn't know if it was going to work, because it was IP, and putting MPEG encoded video with very, very low latency so that we can remotely produce between here and LA was something that was kind of a challenge. So the question, to share a single link for internet traffic, for interactive video production, voice over IP, intercom, and file transfer, so all those traffic in that link, it was not clear that it was going to work. So the question, and that's basically when you start file transfer, is that your link become oversubscribed. So we had to have quality of service on that link to make sure that whatever, because you don't want to carve hard tunnel for each type of data, because then you need more bandwidth and you're paying more, and that's always a problem, of course. But what you want is to be able to, when you don't need to transport video, that everything is available for file transfer, for instance. But if you need to do remote production and you need three video camera and 16 audio that comes here, and that takes roughly 75 megabits of your 155, because we're operating at 25 megabit each, because you want to operate in 422 format for studio quality, and you want to have a delay as little as possible. So we're operating in what Tenberg calls mega low delay, which is only a PPP encoding. And that enables us to do a round trip between here and Los Angeles of about 250 millisecond round trip. So below 100 millisecond end-to-end in one direction, which enables really the people sitting in the production control there to really feel like they were controlling the studio next door. So that if you go to delay that are longer than that, and you go to a 2 second in each direction and 4 second by the time they have the return, etc., then remote production is really not practical. And you have the feeling that you see sometimes on cable television when they ask a question and then they interrupt themselves, etc. So this is what we did install. So it was not clear at the time, because everybody that was using IP infrastructure, like CNN, for instance, would buy huge pipe. Like at the same time that we were doing this mixed network with an OC3, CNN basically built a network between Atlanta, Washington, and New York with OC 192. And basically say, okay, well, we go uncompressed, full resolution, and pipe which are dedicated. So we carved a big pipe for cameras, we carve a big pipe for internet, etc. So good for them, they have the budget, but a small operation like we are don't. So that was key to what we tried to do that. So that was not clear at all that it would work, but it did. So use lowest possible delay, P-frame only, group of picture. Not even sure that you can call it group of picture when it's P-frame only, because group of picture is defined like between two iframe. So, but that also gives that this is not tolerant at all to packet loss of jitter, because I don't know how much you are familiar with MPEG structure here. Are you? Everybody pretty comfortable with that? Yeah. I have another slide at the end of the... So this is oversimplified, but basically iframes are frames that are complete by themselves. So they have all the information, and when you do a typical MPEG group of picture, you have iframe, you have P-frame, which are predicted frame, and you have B-frame, which are bidirectional frame. So in order to be as efficient as you can on the coding, you're using information that are in the past and in the future. But what this does create is longer buffer. So in order to know what will happen in the future, that needs to already happen. So therefore, you need a longer buffer to be able to get data that are basically in the future for the receiving end. So, and when you use only P-frame, then you have less efficient coding. But basically, you have the shortest possible delay that you can have on a compressed MPEG like that. And folks from Tenberg or our friend here, what the other MPEG manufacturer, what's it? Harmonic, could answer more why is that, is the most, gives the lowest delay. However, since there is no frame that are complete by itself, if you get lots of jitter, lots of on your network, or loss of packet, and you can't reconstitute that predicted frame here, it's going to take you many seconds to recover. So that means that as soon as you have a problem in the transmission, you're losing the picture. It's really dramatic, and it takes many seconds to recover. So to use remote production in that way, and to be able to interact with the people on the other side, while so the delay very short, the quality high, and to have that on a mixed network is very hard, because you cannot suffer any jitter or any delay. So you need a very high quality network, and you need a very good quality of service. So when we did the initial installation here, that did work. So we were able to install we were able to install that OC3 and to set the quality on service with the Cisco equipment that we got. But when we grew the network, so this is the network in 2005, then in 2007, that was already more complex. 2007, we still had the OC3 to LA, but between our Colo site and our San Francisco office, now we had dark fiber at that point in time. And we upgraded that dark fiber to 10 gigabit. Well, sorry, I'm not pointing the right thing. So our San Francisco production center was with dark fiber at 10 gigabit. That actually cost less than our OC3. It was longer to install, to get dark fiber and to dig on the street and all of this. But once it was installed in the longer term, it actually lowered our costs as opposed to the local loop that we had before. And we were able to operate that dark fiber at 10 gigabit, and it's a loop, so it's protected. And we have a sales office in New York, which has a fast Ethernet, 100 megabit, so that they're able to view our content, to create DVD remotely, etc., to be able to sell to advertiser. Then we added an OC3 to London. In London, we placed a Colo as well. We have our studio, which is on Stephen Street, which is a building that is co-located with SN Media in London. And then our uplink facility is in Chilworth, and our equipment there is, our broadcast equipment is actually at the uplink facility. We have 3 racks of equipment, and actually all of our broadcast chain is located there. Now, we have no personnel there, and they don't operate that. So they have basic training so that if we need them to reboot a machine or something like that, they can. But basically, we're operating everything from the San Francisco master control here. So the equipment are physically there, but the control is here, monitoring is in control. But if that link ever fails, our playback to air is uninterrupted, because it just keeps playing the list that it has locally until we're able to reestablish contact. And we have, of course, a backup link to that facility. And we have also a link on both places to the internet. In LA, what we did add at that point is basically our LA facility became a campus. So we added 2 other buildings that were nearby, and we used Motorola link at about 140 megabits wireless link to both of those facilities. So even through that link, we were able to use the green screen there and stream it to our production control in San Francisco. One problem that we had when we added that is that we added another vendor to our mix of equipment. So here, when we started with Cisco. And the reason we did start with Cisco is honestly because I didn't know too much about network manufacturer. So I studied computer science at McGill, so I know network from a theoretical basis, but I'm not an expert in networking gears. So basically, we said to Cisco, come here, tell us what we should buy in terms of router and in terms of switches in order to make sure that we can establish the QoS necessary to talk with Los Angeles. But then after that, we had more people here, and we had specialists in networking that didn't like Cisco at all, so they bought Juniper instead. So suddenly we had mixed vendors in our network. And that made our life a little bit harder for the QoS, because now the way that you set QoS on each of those vendors is a little bit different. And we found out actually, we had issue that everything was working fine, and then suddenly we would begin to have drops. So suddenly everything is fine. We do remote production with London. So these guys had the green screen there. We were sending that signal live to the control room here, doing the keying and doing all the work great. The delay was very short, a bit longer than with LA, but still within very easy to work with interactively. But then suddenly, there were drops. So like I said, those PPP frame in MPEG just begin to drop. We lose the signal, and it takes like 10, 15 seconds to recover. And if you have that in the middle of production, that's not good. That makes your content unusable, etc. So at the end, we were able to find out that with many testing and many pain, that the Juniper equipment don't enforce QoS instantaneously. They do so at the next second. So imagine we have the camera streaming there, we're producing, and then somebody decide to exchange a file. So he's downloading a file between the two, and the file is not like a very organized stream of video that's streamed at a constant speed. It's a big file that you send can, for a short time, overload your link. So you send the file, it overloads the link, then you begin to have drops. Then the router, the Juniper router, decide, well, okay, that has lower priority than the video, so I'm going to squash it. But it takes half a second to decide to squash it and squash it. And you have your PPP group of picture that basically is disrupted, and it takes you like 15 seconds to get back. Then the person stopped downloading the file, then somebody else put another file, and then you have that again. So, so that was a hard problem to track, actually. So the reason that I'm mentioning this is to show you one of the main problems that I've experienced in that kind of architecture. Because one of the things that I've tried to build here, if you look around, if you look at the central equipment room that is there, it's basically the whole baseband equipment that we have here for the whole network is there. So it's very, very compact. So what I've tried to do is have as little baseband equipment as possible, and to do as much possible through the network and through file transfer and to central storage, etc., which is a great idea. However, that means that you're using a lot of IT equipment, and that means that broadcast engineers have to work with IT engineers, and IT engineers have to work with broadcast engineers, and those kind of groups don't understand quite each other very well. So IT engineer thinks that broadcast engineers don't know nothing, and they're the one that knows how to set up network, etc. and the reverse is true as well. So I would say this was probably one of the main challenge to build that sort of facility, which is as much based as network and on central storage and on IT technology as we did, is people understanding the other side of the business.
So Stefan, bring it up. On this one issue between different manufacturers of routing switchers, network routing switchers, how did you solve that problem, or did you just at certain times make it to where people were not shipping files?
No, well, you know, at first, for sure, we had to tell as people, okay, stop sending files, you know, taking the phone and say, stop sending files. But at some point, we were able to work it out and to get an upgrade, an unsupported upgrade from Juniper that does enforce the QoS instantaneously rather than at the next second, basically. So that did solve the problem. It took many, many months to solve the problem, but it did finally solve it. But what I mean is that it's not impossible to use different vendors in an architecture like that, but it opens up the door to multiple challenges because different network gears can react differently. So when you're in a mixed environment like that, and you say, okay, well, we had this here, it's working perfectly. Why is it not working perfectly on that? So that link here between Los Angeles and here was working perfectly, and that link was not. But the quality of that link was as good as this one. So it was not because the delay was much longer, or it was not because that link had much more packet loss. It was actually our provider of those links is Level 3 Communication, and they're a tier 1 provider of network connectivity, and the quality of the link that they deliver us, very, very good, very low jitter, very clean, almost no error in packet, etc. So you know you can extrapolate. If you don't isolate each factor one by one, you can say, well, of course it's because it's London. Microphone.
Did you have audio sync issues?
Audio sync issue, well, yeah.
Or how did you deal with the audio sync issues?
Okay, well. In the lifetime of this station, we had multiples. We had issue at the beginning with QuickTime. And actually, that was hard because we were at the beginning and we were just getting on air with all this new technology, with the central storage playing directly to air, etc. And then we see wacky out of sync issue. And then, of course, you begin to try to isolate what it is, and you get lots of shit from the management because, frankly, to have sync issue is not fun. So, and especially our president of programming is very touchy on the sync issue. So, and of course, you begin to say, well, we think it's QuickTime, you know, by isolating things. So, and I was actually, at some point, I was sure that it was a QuickTime issue. And of course, we have links with Apple because our chairman, Al Gore, is also on the board of Apple, etc. So, you know, there's ways that we can get at Apple. But Apple basically saying, it's impossible. It's not us. The problem has to be Bug TV. So it has to be Bug TV. So everybody's putting pressure. Apple doesn't want to look at stuff, etc. So we had to replicate the problem with Apple-owned software, basically using their QuickTime demo and showing them. And I had to go to meet their QuickTime team in Cupertino with our media and with their software to show them, look, there's no Bug TV here, and it's out of sync. Look at that. And then the guy from one of the programmer of the QuickTime team sat down on the floor and said, "It's impossible. It's impossible. So he was just keeping saying it's impossible, but there it was in front of him. So it took them like a few weeks to realize that it was indeed possible. And then the fix they gave us was, because it was the early days of QuickTime 7, so they gave us an undocumented feature to put a key in the QuickTime player to force QuickTime to use the QuickTime 6 audio architecture. And that fixed the issue, and it took them about a year and a half to come with a fix in QuickTime 7 to fix the sync issue. So yes, when you're working with cutting edge technology and things like that, those kind of things do happen. More generally, there's of course the general problem with MPEG. MPEG is non-deterministic, so when you send the signal, even if everything is on sync when we send it from here, when it goes to satellite and to home decoder, it gets to the home decoder, it can be out of sync sometimes. Granted, those are not necessarily huge amount of out of sync, but sometimes it is, and sometimes it requires to switch channel or to reboot the home terminal in order for that to come back. And but this is something that the industry entirely is grappling with. I'm part of SMT standard committee, going to those committee meeting each 3 months, and it's a big issue. Somebody from Turner was saying, guys, every manager thinks that only their channel is out of sync. So because they're paying attention to their channel, and people at Turner are saying, we're the only ones that are out of sync. And heads will roll if you don't fix that. So that problem is, of course, an industry-wide problem that, unfortunately, because when they did wrote the MPEG standard, they didn't wrote in it that you had to maintain sync. So people that did manufacture chipset had to pay more to maintain that, so they didn't because it was not written that it was necessary. And so, yeah, you can, in the forward manner for new standard and stuff, you can put technique there to solve the problem, etc. But you're not going to do that in all the chipset that are in all the decoders already in homes. So that's a much wider problem than here.
On that question,
Microphone?
I know, I'm waiting for it.
Where is it? Yeah, okay.
On the question that you're addressing right at the moment on that sync, it seems that there is a problem beyond the MPEG and the chip, in that once the video and audio stream have been delivered to the computer hardware itself, the propagation delay through the audio channels versus the video channels within the computer box, irrespective of how neatly the MPEG chip has sunk it up or whatever, is still another layer of indeterminate missyncing. And I don't know whether anybody is looking at that and making allowances for it, but it wouldn't take much to put a control panel in line with an audio stream and add another 30, 40, 50 milliseconds of delay to an audio stream that one computer has and another doesn't, just because of some additional software process that goes through or whatever. Your comments?
Yeah, well, you know, it's now we're we're a bit far from the core subject, but I don't think that when you have control on your computer, when it's not part of a set-top box that is done at multiple copies and that you can really do nothing about that chip. When you can fix it by software, then it's not a big issue. And I think that if it's in a computer today have enough processing power that they can address those things more easily that when you have things that are burned into silicon, like in the MPEG decoder chip that are in set-top boxes. So I'm much more addressing here issue of set-top boxes than of software decoder or computers.
The result is largely the same in the same picture going either place.
Well, the problem is that if you don't have the data that tells you what is in sync, how do you correct it? And that's the problem with the MPEG transmission, is that you don't have that data. If you add the data that tells you that a certain that this particular data has a timestamp, and that particular audio and that particular video has a timestamp, and you can sync it, then you can in post-processing you can resync it. But the problem is that it's not part of those stream in MPEG. So if by design your chip doesn't ensure that it's maintained that in a deterministic way, then you have nothing that tells you what to correct. And since it's something that changes, like if you add one value and you can compensate for that value, it will be solved. But it's not. It's something that is constantly changing because of the non-deterministic nature of MPEG.
What's happened to the presentation timestamp? It's inside the MPEG stream, whose purpose is to maintain synchronization.
Sorry?
What's happened to the presentation timestamp that is part of the audio and video stream to maintain synchronization? Because that is part of MPEG.
That's part of MPEG, but as Stefan was saying, okay, it wasn't a requirement to use at the time. So it's not, all chips don't necessarily use the timestamps. Stefan, we are, getting a little late in the evening. If we could try to wrap it up in the next 15 minutes, be good. Okay.
Well, like I said, we could have been talking here for 3 weeks or something like that on the subject that I have. Just a quick view, we just, in network-wise, we added in 2009 now, we have in LA, we have yet another site. So we did replace one of our link with Gigabit Link, which is FSO, which free space optic. So we have a Canon free space optic at 1 gigabit between those two buildings. And we have our Motorola wireless between those here. We did add Colo in Milan. We did add our Milan production office and our equipment for our Italy broadcast at Sky in Rome. So this is basically how our network looks now. And now we have solved the QoS issue, so it does work. Just a quick thing here saying that the mains 11 of our playout, we have a main and a backup bug server, which are running on the Apple Xserve. We stream directly from the Isilon. We go through a router and we go through our master control chain, which are essentially Miranda, image stores, and Intuition, plus a lot of other devices that we have for additional graphic, which are really Macintosh's servers and also flash machine. And all of this, of course, is connected through network. I'm going to go just quick on that. I have too much effect on that slide. So this is the architecture of the Isilon that we're using for basically all of our central storage need in the various countries that we have here. So it's really NAS architecture where all the machines are connected through gigabit Ethernet to the Isilon nodes. So this is what it looks like basically. So a few notes that I wanted to say that in general I have learned through this process is that when you have projects that are very timely and complex, it's been invaluable really to work with system integrator as opposed to doing it yourself because, and especially when you're doing a new country like the UK and Italy, I know probably not a lot of you will need to do that, but believe me, if you have to establish credit and accounts with all your supplier, it will basically kill your project. So the key there is that working with a system integrator that is already established and already has all those accounts will save you tremendous amount of time because you have one contract to deal with, one per people to do. So the contracting process is very long. So if you try to do all that with independent supplier and bring stuff together, it's going to add months and months to your project. Network installation is long, and especially when you're going to Europe, it's easy to have lead time of many months to have a good network connectivity like an OC3 or a DS3 to facility. So it's something that if you do a project, the first thing that you should be thinking, if possible, is the network, and you should order it. So our architecture, like I said earlier, it's distributed. So we have all of our equipment, basically for UK and Italy, is at the uplink site, and we monitor everything from here, from the master control that is right in the window there. Challenges, we had, like I said, expertise. So IT folks typically don't understand TV, and TV people don't understand IT. Time frame, people that are creative by nature always want to change things. So they will tell you something, but then 2 months after they want something slightly different and so on. And when you have to order equipment and to put that together, you're not quite as flexible. So that did represent a significant challenge as well. Putting central storage for editing with more than 100 stations, editing directly from there. The non-Windows signal path, mixed data network, location remote control, a path to HD as well that I didn't address, but everything that we have here has been basically built switchable. So all of our equipment can do HD or SD, is multi-standard. Our production control is. We're doing here daily production in 625 with the UK and switching everything back to 525. So we can handle multiple formats. All the computers have cards that can support HD and SD. Monitoring has been an issue as to get real quality in multiple format, you basically need CRTs. And CRTs are hard to find now, and they're very expensive, those that you do find, like the BVM monitors. And there's really not out there a real good alternative for broadcast quality monitoring that tells you the reality that are non-CRTs. So this does represent a challenge in terms of being ready for HD. But here, we built the facility to be able to handle that from the beginning. And for a few years now, everything that we produce ourselves in terms of shooting in the field, we do in HDV. So even though we don't have an outlet on cable in HD, things that we shoot ourselves are. And of course, the budget is always a challenge. There are two places basically where I'm saying I never do compromise for that, and you should not, is power. So make sure that you have very good power and properly configure technical ground that will save you a lot of trouble, and reference. So here we did elect to use the Evertz SyncGen that can do basically all the existing format in all the things, the HD and SD, and as well as test signal, not only reference and test, and synchronize with GPS to get a reliable source time. And those devices give us NTP as well, because most of our server here, we don't use external timecode reference. We use NTP in terms of synchronizing them and keeping them on time. And this is actually a problem that we solve, but to something that never existed yet. But I decided to put that slide there just to address that question of mixed HD and SD. So early on, we said, well, we don't know when we're going to need to go HD, but it may be 2 months from now, it may be years. But we say at some point, we'll need to have SD sources and HD sources, and we'll need to generate error signal in SD and an error signal in HD. So we said what we need to make sure is that graphics for each of those have their own branding in their format. So we said we did put together a complete chain for HD for graphics, master control, as well as SD. But what we did is that we did put a cross converter in the middle there. So we said whatever you feed to the cross converter, if you feed SD, it's going to always output an HD stream and an SD stream. And if you switch from one to the other, it's going to do the reverse. So, so that ensures that basically you can do a transition that is smoother than having to change all the document that you have, all the movies or all the files that you have from SD to HD, basically. So this is a piece of things that we did originally. We never use because this HD output don't exist yet, just because of the demand from the distributor and what is available for us to use. But it's how we addressed it. So that was basically what I wanted to share. I'm very happy of all the questions. Maybe I can take 1 or 2 questions if you have.
See, last time we were here, which I think was a year ago, this last July, and we had a tour, I asked a question on archiving your material, and was kind of told that, okay, you guys don't believe in archiving. Is that still the case? And if not, what do you do about old material?
That's a question for Joe.
No, we do archive our material. We've been using LTO4 tape to bring it down. We haven't yet invested in a sort of refrigerator-sized robot, because essentially what we see happening is that we throw off more media every year than would be reasonably able to scale along with our ability to buy shelves for the fridge. So we're essentially considering the media archive to be a kind of a long tail situation where we're accepting a certain slower SLA, which involves a human being scurrying to grab a tape and jam it into a drive in order to process or restore, than would be available if everything were sort of at a nearline configuration. But so far that's worked out really well for us. For certain items, high value like pods, we actually are using just sort of spare on the shelf hard drives to be able to enable a speedy and/or massively parallel restore, like for instance when you launch a channel in Italy and need to dub 100 pods in a month.
So what about your, you rely 100% on RAID technology in the server in case you've had a disk failure, or do you also do backups of what the nodes are?
Very, very little of the spinning disk storage is just backed up directly to tape. The primary usage for the tape is for an archive workflow where it's being removed from the spinning tier. On the Isilon cluster storage, which has an architecture which is extremely robust, you can lose multiple drives in a node. You can lose an entire node from a cluster, and still, like, the users don't really even notice that there's something wrong unless they're, at a very peak demand period. That's the kind of day-to-day backup scenario. The exceptions to that are items on the Isilon which we feel are meant to persist there long term, like masters or graphics toolboxes or things that aren't on a journey from recently being ingested on its way to being sort of rephysicalized on tape and as part of a workflow. Generally speaking, no piece of media stays on the Isilon for more than 180 days. Most of them for 40 to 60. Again, we're current, so the media moves through the scratch space relatively quickly.
I guess my question is for Stefan. How are you guys dealing with standards conversion, going from 525 to 65 and back, and how you're dealing with the audio time pitch change issues?
Well, for the most part, we're going through a baseband conversion. So for the most part, we're not going through a file-based conversion. So we have two Shibetsuku standard converters, and basically we're just playing one standard, bringing back to baseband, going to the Shibetsuku, and re-recording it basically. So there's no audio pitch issue because we're basically doing it at regular speed. We're not changing the speed there. And the reason we did choose the Shibetsuku over, for instance, the Snell and Wilcox is for the graphics, because although the Snell and Wilcox may be superior to in some motion vector estimation in terms of preserving the integrity of our graphics, and for us at Current, the graphic package is important, and rather than redoing the whole graphic package on our pod and the other standard, we wanted something that enables us to take a finished pod in the US, transcoding it for the UK, and be usable with the same graphics. And there, the Shibetsuku was clearly superior in the preserving the quality of the graphics. And this is also the reason why we're doing through the pain of going baseband rather than using file-based transcoding.
It's certainly won the shootout versus file-based.
No other question? Well, thanks a lot for your great question. Thanks for your time. I want to thank the whole technical team here that have been part of this. All of this was done on their own time. And I want to thank Current also for enabling us to do this session, and to SMT for organizing this.
Once again, I'd like to thank everyone for attending, and thank Current TV, and especially Stefan and Joe for the information they presented. I'm sure if you've got some questions, they might stick around and ask them one-on-one. And one thing we didn't do is we didn't plug SMPTE membership. Now, meetings are not necessarily for restricted to members, but we do like to take and show, okay, how SMPTE membership can actually help the journal and some of the other things that are available. So please consider that if you are not a member.
Go to SMPTE.org.
Go to SMPTE.org. Be careful because there's a SMPTE.com, but SMPTE.org has all the information. Once again, thanks for coming, and I hope to see you at another meeting. Thank you.
Sorry? For what? Well, for instance, there are challenges.